Now to an incredible find overseas, an elaborate series of stone monuments believed to have been hidden for thousands of years, not far from the famous site of Stonehenge.
Now, a new analysis shows that the 6-ton iconic altar stone at the heart of Stonehenge originated from northeastern Scotland.
Stonehenge has stood on Salisbury Plain for close to 5,000 years, and in all that time, the more researchers studied it, the less they felt they truly understood it. Every answer raised 3 new questions, and the monument never gave anything back.
Stonehenge is like a letter from the deep past. It's there, it's physical, you can't ignore it.
Then, in desperation for answers, scientists fed 3 centuries of accumulated data into AI systems powerful enough to hold all of it at once. What came back shocked the world. So what exactly did it find? Join us as we break down what AI uncovered when it reanalyzed Stonehenge. The stone that nobody knew was Scottish. There is a stone lying flat at the center of Stonehenge that has been misidentified for 100 years. You see, this stone has not been misidentified in a way that required anyone to be careless or incompetent. It has been misidentified because the tools to identify it correctly did not exist until recently, and by the time those tools arrived, the assumption about where it came from had been sitting unchallenged in the literature for so long that nobody thought to press it.
But what does it mean?
So Stonehenge is very interesting in that it evolves over a very long period of time. The first thing that goes up at Stonehenge is not there anymore. It's the 56 holes that today are known as the Albury Circle.
That stone is the altar stone, a 6-ton slab of gray-green sandstone partially buried beneath 2 collapsed sarsen blocks at the monument's heart. And in August of 2024, a team led by PhD student Anthony Clarke from Curtin University in Australia published a study in the journal Nature that dismantled a century of settled assumption in one pass. Now, be sure to watch until the very end, because what this research uncovered will give you a whole new understanding of what really happened. The study used handheld X-ray fluorescence analysis and radiometric dating on fragments of the altar stone held in museum collections.
Previously unknown civilization living right here of Bronze Age people. And that's who built Stonehenge.
Examining the age and chemical fingerprint of mineral grains within the rock at a level of precision that earlier researchers had no way of reaching. The altar stone's mineral grains are mostly between 1,000 and 2,000 million years old, with other minerals dating to around 450 million years. That combination of ages matches nothing in Wales, nothing in southern England, and surprisingly enough, it does relate with any rock formation the field had previously considered. Instead, the altar stone matches the Orcadian Basin in northeast Scotland with a specificity that Clarke described as remarkable and that his team confirmed through repeated analysis. Co-author Dr. Robert Ixer of University College London called it a genuinely shocking result. With this revelation, it is pretty obvious that the altar stone is Scottish. It has been Scottish for 4,500 years, yet nobody knew all along. Now, what that means logistically is the part that refuses to settle quietly. The oldest known wheel in Britain is around 3,000 years old. The altar stone arrived at Stonehenge around 2,000 years before that. It weighs 6 tons. It measures 5 meters in length. Moving it from northeast Scotland to Salisbury Plain, without wheeled transport, without metal tools, and without any of the infrastructure that makes large-scale logistics manageable in any era, required a level of social coordination, long-distance communication, and sustained collective effort that the standard account of Neolithic Britain had never credited those communities with possessing. The researchers who published the study believed the most plausible route was maritime, a journey by sea along the coastline of Britain, which implies seafaring capability in the Neolithic period that has not yet been confirmed by any surviving physical evidence. The ships, if ships were used, did not survive. The route has not been mapped. What remains is the stone and the 4,500-year-old question of how it got there. Stonehenge is also the only prehistoric stone circle in Britain built entirely from imported rock. Every stone at the site was carried from somewhere else. The sarsen uprights of the outer ring came from Marlborough Downs, roughly 25 kilometers north. The bluestones came from the Preseli Hills in Wales, over 200 kilometers away. And the altar stone came from Scotland, making it the longest recorded journey for any stone used in a Neolithic monument anywhere. Archaeologist Mike Parker Pearson has proposed that this pattern was not accidental. He argues that Stonehenge was a deliberate gathering of the most significant stones from across the length of an island that was politically fragmented, and that the monument served as a physical record of alliance between communities who would otherwise have had no permanent connection to one another. On that note, it is important to note that the altar stone was not just a building material. It was a statement, pressed into the ground at the center of a monument meant to outlast every generation that contributed to it. Archaeologist Alasdair Whittle of Cardiff University described the late Neolithic as an age of heroic feats of shared labor and long-distance movement. The altar stone is the most extreme evidence of that description anyone has yet found, but it doesn't end there. Most visitors to Stonehenge never know the pits exist. They are not the kind of feature that draws the eye. Instead, they are a ring of 56 holes, set just inside the outer earthwork, named after 17th century antiquarian John Aubrey, who recorded them without fully understanding them. For 3 centuries after Aubrey's notes, the holes were treated as background, the kind of incidental feature that gets documented and then set aside while attention moves to the more visually dramatic elements of the monument. Then, in 1963, astronomer Gerald Hawkins of Boston University published a paper in Nature proposing something that the archaeological establishment at the time found almost offensive. His proposal was that the 56 Aubrey holes were not incidental at all, but were a working astronomical instrument designed to track the moon's movements across time with a precision that implied sophisticated observational knowledge. One very striking revelation here is that number 56 is not arbitrary. The moon's orbital path does not stay fixed relative to the Earth. It wobbles through a cycle that takes 18.6 years to complete, a period known as the lunar nodal cycle, during which the moon's rising and setting points drift across the horizon and then return to their starting position. Multiply 18.6 by 3 and you get 55.8, which rounds to 56. The ring of Aubrey holes encodes 3 complete lunar nodal cycles in its count. Hawkins proposed that markers could be moved between holes at regular intervals to track where the moon was within that cycle and to predict in advance when lunar eclipses would occur, because eclipses happen at predictable moments within the nodal cycle. Fred Hoyle, one of the most distinguished astrophysicists of the 20th century, subsequently examined Hawkins's work and extended it, confirming that the system was mathematically coherent and that it would have functioned as described. As of today, the debate around Hawkins' specific claims has continued for decades, with some archaeologists challenging the mechanism while accepting the broader astronomical significance of the site. What is not seriously disputed is the significance of the lunar nodal cycle to the monument's builders. In 2024, English Heritage launched a collaborative project with the Royal Astronomical Society and archaeoastronomers from Bournemouth, Oxford, and Leicester specifically to observe and document the moon's behavior at Stonehenge during the major lunar standstill, the point in the 18.6-year cycle when the moon reaches its most extreme positions on the horizon. The project ran from 2024 through mid-2025. The fact that one of the world's most respected heritage organizations thought this cycle significant enough to mount a multi-university research project around it in the present day speaks to how seriously the field now takes the astronomical dimension of the monument. Those 56 holes were not dug randomly. The number is too precise, and the cycle it encodes is too real for that conclusion to hold. Now here is where the story shifts in a direction that nobody standing at Stonehenge in 1720 or 1900 or even 1980 could have anticipated, so keep watching for more. What the AI was actually looking for. For most of the history of Stonehenge research, the limiting factor was not ambition, because researchers were curious, rigorous, and often brilliant. The limiting factor was the sheer volume of data the site produced and the impossibility of holding all of it in view at once. A geologist studying the altar stone was not simultaneously modeling the acoustic properties of the sarsen circle. An astronomer mapping solstice alignments was not cross-referencing the isotope signatures in cremated remains. An archaeologist examining tool marks on the trilithons was not running lunar orbital calculations against the spacing of the Aubrey holes. Each researcher worked on a fragment of a picture that was always too large for any one person to see whole. That is precisely the problem that AI-assisted analysis is built to solve. When researchers began feeding the full Stonehenge dataset into systems capable of processing millions of variables simultaneously, geological surveys, acoustic measurements, astronomical models, architectural records, burial data, isotope analyses, what those systems returned was not a single answer. It was a set of convergences, points where findings from entirely separate research traditions lined up against each other in ways that human study, working one fragment at a time across separate academic disciplines, had never been positioned to notice. The AI did not discover anything that was not already in the data. What it did was hold the entire data set at once and ask what it all meant together, rather than what each piece meant separately. And the answer it kept returning to was that Stonehenge was more precisely engineered, more deliberately designed, and more sophisticated in its embedded knowledge than the sum of any individual research tradition had been able to demonstrate on its own. The acoustic findings are a clear example of this convergence in action. The geologists already knew which stones came from Wales and why those stones were unusual. The acousticians already knew the sarsen circle produced specific resonance effects, but it was only when both datasets were examined together, bluestone composition alongside acoustic modeling of the complete monument, that the pattern became legible. The stones selected for their tonal properties in Wales were placed at specific positions within the sarsen circle where their sonic characteristics would interact with the resonance the larger structure was already producing. That is not two separate observations. That is one integrated design, and it took the ability to hold both observations simultaneously to see it as such. Stay with us, because what follows is where that integration produces its most uncomfortable result. What the circle does to sound. In the early hours of a spring morning in 2009, two acousticians from British universities walked around Stonehenge popping balloons. This was not an eccentric exercise. It was science. Rupert Till of the University of Huddersfield and Bruno Fazenda of the University of Salford were conducting the first serious acoustic field measurements ever taken at the monument, using the sharp crack of bursting balloons to generate a consistent sound source whose reflections and reverberations they could then measure against the stones. What they found, and what subsequent work by Trevor Cox and Fazenda using a 1:12 scale model of Stonehenge confirmed in the Journal of Archaeological Science in 2020, was that the monument is not acoustically neutral. It was never acoustically neutral. The arrangement of the sarsen stones functions as an acoustic boundary that reflects sound inward, trapping it within the circle, while simultaneously dampening sounds from outside. Anyone standing within the ring during a ceremony would have been acoustically isolated from the world beyond the stones. And that's only the beginning. The reverberation time measured inside the scale model averaged around 0.6 seconds for mid-frequency sounds, an effect that Trevor Cox described as boosting the ability to hear voices and enhancing the sounds of drums or other instruments played within the circle. Earlier field research by Till had identified the low-frequency resonance effects, including what he described as a powerful resonance at 47 to 48 Hz When the full Maryhill Monument replica in Washington State, a full-scale concrete reconstruction of Stonehenge, was tested acoustically. Low-frequency resonance in that range sits below the threshold of conscious hearing but produces measurable physical effects in the human body, including alterations in heart rate and physiological responses associated with heightened emotional states. Till's research suggested that the acoustic properties of the original complete monument, before stones fell and the circle lost its structural integrity, would have been considerably more powerful than what survives today. The broader point from all of this research is that Stonehenge was not simply a visual monument or an astronomical one. It was a space whose physical geometry shaped what happened to the human body inside it, using sound. Whether that was a primary design consideration or a consequence of decisions made for other reasons is something the data points toward but cannot definitively settle. What the researchers are clear about is that the effect is real. It is consistent across different methodologies and different research teams, and it would have been experienced by everyone who took part in ceremonies inside the circle. The monument did not just align with the sky above it. It worked on the people standing inside it. And here comes the part you don't want to miss. What the builders were actually selecting for. The bluestones at Stonehenge have puzzled researchers for decades, and not because of what they are, but because of why anyone thought they were worth the journey in the first place. You see, Stonehenge sits on Salisbury Plain, surrounded by perfectly usable local rock. The builders ignored all of it. Instead, they walked to the Preseli Hills in southwest Wales, more than 200 kilometers away, and came back carrying stones that were geologically different from anything available nearby. For most of the monument's research history, the standard explanation was symbolic. The stones came from somewhere meaningful, and that meaning traveled with them. That answer was always a little unsatisfying. In 2013, researchers Paul Devereux and John Wozencroft of London's Royal College of Art published a study in the Journal of Time and Mind that replaced it with something far more interesting. After testing over 1,000 stones along the Carnmenon Ridge in the Preseli Hills, the exact area from which the Stonehenge bluestones were quarried, they found that between 5 and 10% of the rocks in that landscape produce clear, sustained tones when struck, ranging from bell-like metallic rings to deeper resonances resembling gongs and drums. In certain areas of the ridge, the proportion of ringing stones climbs to 15 or 20%. The bluestones are lithophones, natural musical instruments, and the landscape they come from sounds unlike almost anywhere else in Britain. When the researchers then tested the bluestones at Stonehenge itself, the first time acoustic testing had ever been done on the monument's stones in place, the results confirmed it. The bluestones still ring. They produce the same tones as the stones sitting in the Welsh hills right now. The builders did not just bring rocks from Wales, they auditioned them. They came back with the ones that sang. What comes next makes even that look like a footnote. Set the geology aside entirely and consider only what the monument does on 2 specific days of the year. On the summer solstice, the sun rises behind the heel stone in the northeast, and its first light travels directly into the heart of the circle. On the winter solstice, the sun sets to the southwest through the Great Sarsen Trilithon. English heritage, historic England, and every serious astronomical analysis of the site since William Stukeley first noted the midsummer alignment in 1720 have all confirmed the same thing. The alignment is not approximate. It is exact. A laser survey of the monument went further and found that the stones framing the solstice axis are the most carefully worked stones at the entire site, shaped with hammer stones to create vertical sides that would frame the movement of the sun precisely. Someone decided which stones needed the most precise finishing work before a single block was moved into position. Construction ran in phases from roughly 3000 BCE to 2000 BCE, a span of 1,000 years, and the solstice alignment held as the organizing principle across every single phase of that entire span. that intention outlasted every person who contributed to it. Interestingly enough, a study published in the journal Scientific Reports added one more dimension that no one saw coming. Isotope analysis of cremated human remains recovered from the site found that at least 10 of 25 individuals analyzed did not spend their lives on the Wiltshire chalk where Stonehenge stands. The most plausible origin the researchers could identify for those individuals was West Wales, the same region the Bluestones came from. The stones and the people buried among them traveled the same roads. Stonehenge was not a local monument. It was a destination, drawing people and materials from across the length of Britain toward a single point on Salisbury Plain, for reasons that still refuse to resolve into a single clean answer. And this is the part of the story that changes everything you thought you understood about who these people were. The most uncomfortable finding of all. Everything examined so far pushes the builders of Stonehenge further from the primitive picture the textbooks have always drawn of them. More connected, more deliberate, more sophisticated. But the final finding from the reanalysis does not make them look more impressive. It makes them look like a civilization watching something slip through its fingers and unable to stop it. When researchers examined the full building sequence at Stonehenge, which stones were placed in which phases, and what the quality of workmanship at each phase revealed, the pattern that emerged runs in the opposite direction to how any technical tradition is supposed to develop. Normally, each generation refines what came before. But when it comes to Stonehenge, the sequence shows is the reverse. The earliest phases of construction demonstrate the deepest command of the monument's design principles, which featured the most precise stonework and the strongest acoustic effects. But as the building continues across centuries, the precision loosens. Later stones sit further from their ideal positions, the work is less carefully finished, and later arrangements produce weaker versions of the effects the earliest builders achieved with apparent ease. The acoustic research from the University of Salford's scale model sharpened this picture in a way that is hard to shake. The bluestone arrangement was reconfigured multiple times across the monument's construction history, and those reconfigurations made no audible difference to the acoustic properties of the circle. The people moving those stones knew they mattered. They knew they belonged inside the circle. What they no longer fully understood was why specific positions produced stronger effects than others. They were following the shape of a tradition whose deeper reasoning had gone quiet, somewhere in the generations between them and the people who first designed it. This was not incompetence, but distance. The distance of too many lifetimes passed without the full explanation surviving the crossing. That pattern of mastery at the beginning, which slows erosion across centuries, is what happens when knowledge lives entirely in memory, and the chain of transmission develops gaps that no one alive can see clearly enough to repair. Around 1600 BCE, Stonehenge was deliberately closed down, not abandoned. Someone made the decision to end it. Whether that decision came from the recognition that what the monument had originally been built to do could no longer be done at its original level, or from something else entirely, is a question the data cannot yet answer. What the data does say is that the monument peaked at its very beginning, and everything that followed was the long, slow distance between that peak and the moment someone finally stopped. And it is precisely here, standing at the end of this story, that the value of what AI has brought to Stonehenge becomes impossible to dismiss. No single researcher, working in a single discipline, across a single career, could have held all of this simultaneously. The Scottish stone, the lunar mathematics in the pits, the acoustic engineering, the singing stones from Wales, the declining precision across 1,000 years of construction. These findings existed in separate fields, published in separate journals, studied by people who rarely read each other's work. What AI did was refuse to treat them as separate. It held the whole picture at once, and what came into focus when it did was a monument far more deliberate, far more sophisticated, and far more human in its eventual loss than anyone had previously been positioned to see. And now, with all of this laid out together, we can finally appreciate what becomes possible when the most ancient mysteries on Earth are handed to the most powerful analytical tools humanity has ever built. So let us talk about this in the comments below. Which finding from the reanalysis hit you hardest? The altar stone that turned out to be Scottish, moved before the wheel existed, or the 56 holes encoding the moon's 18.6-year cycle in their count? Share and subscribe, and click the next video on your screen. You will not want to miss it.